Quadratic sequence. The first thing I want to point out to you is that a sequence is a number pattern. So those two terms are synonyms for one another. If you see the word sequence, it means a number pattern. From all the years of high school, you remember that we've done a different list of number patterns or sequences. You're familiar with the linear or the numeric or the arithmetic sequence, which is has a constant difference, right? So if I said 1 plus 2 gives me 3 plus 2 gives me 5, this is a arithmetic sequence. We are going to look at arithmetic sequences in the next session. Then we are familiar with a geometric pattern, and last year in grade 11 you looked at quadratic sequences. So today we are going to start with a quadratic sequence, and I just want to refresh your memory, and I need you to be able to do this. In this short video we're going to do this slide that's in front of you and one example, and then we're going to have another video with example number 2. So the first thing I want to point out to you is the definition of a quadratic sequence is a sequence with a sequence of numbers with a common second difference between the consecutive numbers. What does that mean? When we did the arithmetic sequence, you added 2 to get to the next one, right? But when you are doing a quadratic, your constant difference, that plus 2, exists over here on the second difference. Now it's not always plus 2, I'm just using this example, but it's on the second difference. What do I mean by that? Remember that we have our terms on the top, so this would be term 1 and term 2. Our first difference would be term 2 minus term 1, and then our second difference again will then end up, if this is term 2 and this is term 1, term 2 minus term 1. Don't worry too much, we are going to practice this, so just try to get your head wrapped around this, okay? Okay, so let's look at the slide. On the slide I have the definition, and then I also have the equation. This here is our equation for the general solution. You will most of the times have to figure out the general solution. Sometimes even if the question is not asking for it, you will need it in order to answer subsequent questions. The next thing that I have on the screen is this diamond pyramid shape. This you have to memorize. So this is your formula, like y equals mx plus c. This is your formula that you have to know off by heart. You need to be able to produce this from memory at a drop of a hat. So please memorize this. On this you have 3 tiers. Term 1 is equal to 1a plus 1b plus c, or ax squared plus bx plus c. That is the value for the first term. And then the second term would be 2 times a. This looks, yeah. So what I want you to see here is you have term 1's value, term 2, 3, 4. Notice that the b value is the same as the n. The b value is the same as the n. The b is the same as the n. I'm trying to show you how to get this no matter which term I ask you. For example, if I ask you what happens if n equals 7, then you know that it's going to be 7b, right? Notice that c is always 1. So 7b plus c, plus c, plus c, plus c, plus c, always plus c. Then what happens with a? A is always going to be n squared. So this is 1 squared, this is 2 squared, which is 4. 3 squared is 9, 4 squared is 16, 7 squared is going to be 49. So that's the first thing I want you to see about this pattern. Layer number 1, that is your question. Then you are going to go to dismantling it. So your first difference is going to be a subtraction, right? The first difference, if we look at this one here, it's going to be 4a plus 2b plus c minus 1a plus 1b plus c. But because we're subtracting, you're going to change all the signs to subtraction, and you get C minus C is 0 or nothing. 2b minus 1b is 1b, and 4a minus 1a is 3a. 3a plus b, that's how you get that. And the same applies to all of your first differences. It's term, it's the second term minus the first term, the third term minus the second term, fourth term minus the third term. You're familiar with this pattern. Now, when you get to the second difference, your second difference is going to end up being, as you can imagine, it's going to be this 5a plus b minus 3a minus b, which ends up being b's disappear, 2a. Same thing here, 7a plus b minus 5a minus b, b's disappear, and you end up with 2a. So your second difference is always going to be 2a.